Good day, folks. Let's look at the photoelectric effect. Photoelectric effect, we have a metal here, a metal with electrons on its inside it. And then when the light is incidented, this is the light energy, is incidented on the metal. If the electrons are ejected or emitted from the surface of the metal, they get their energy, and we no longer call them electrons, we call them photoelectrons. Now it says electrons removed like this are called photoelectrons, and electrons emission, so they are emitted there. So this process of ejecting or emitting electrons, we call it's a photoelectric effect. Sorry. And the photoelectric effect, you must be able to define it as the process whereby the electrons are ejected from a metal surface when a light of suitable frequency is incidented on that surface. So this light must have a suitable frequency, right? Which means it must have an energy, right? And sorry, the wavelength as well. And these electrons here, they have a minimum energy that they need. We call it's a work function. And these electrons, they have a minimum frequency that they need, which is this suitable frequency that they need. We call it's a threshold frequency. And these electrons as well, they have what we call it's a wavelength. It's a threshold wavelength, which is it's the maximum energy that they need, right? Very important. So this phenomena, guys, it's a photoelectric effect, right? Ejecting. Now you must be able to define what is a work function, what is a threshold frequency, what is a threshold wavelength. Photoelectric effects suggest that light consists of particles. So what photoelectric effect, it provides an evidence like that light is a what is a particle. And this changed the scientific understanding of light. It helped to develop the quantum theory of light, which consists of photons. Let's define the terminology that I've spoken about. The cutoff frequency or the threshold frequency, it's a F with a subscript 0 there. It's the minimum frequency of light needed to eject or emit electrons from the certain metal surface, right? Stick to the exam guideline when it comes to that. The cutoff wavelength, when we talk about the cutoff wavelength or the threshold wavelength, is the maximum wavelength of light needed to emit electrons from a certain metal surface, right? Now, very important to note, the frequency needed to be greater than a minimum, and the wavelength is smaller than the maximum. So the frequency needs to be greater than the minimum, and the wavelength need to be smaller than the maximum. Very important. We have the energy that we call a work function that the electrons need to be ejected from the metal surface. We call it's a work function. Is the minimum energy that the electrons in the metal needs to be emitted from a metal surface. So the formula for the work function is WO is equal to HF, just like the formula for energy. Energy is equal to Planck's constant times frequency, but this is the frequency of light, and this is the frequency that is needed by the electrons. The H is the same, which is the Planck's constant. Very important for this definition, guys, to understand. When does the photoelectric effect occurs or and do not occur, right? When a light is incidented on the metal surface and nothing happened, This simply means that the energy of the light is lesser than the energy of the electrons, which means the energy of the light is lesser than the work function, which is the energy that is required by these electrons, right? And let's look at the second case. The light, which is, this is the red light, guys. So now we use a different light of different energy. Green, it has a bigger energy than red. So the light is incidented on the metal, or one electron or an electron is ejected from the surface metal. That means here the photoelectric effect did occurred right here in this case, right? But it means that the energy is equal, the energy of the light is equal to the work function. There is a photoelectric effect here. The photoelectric effect occurred here. No photoelectric effect occurred here, right? So here, so these electrons, they're just sitting on top of the surface of the metal because there's no extra energy. The energy that was needed, it was exactly the same that was given there. So let's look at when a light of different intensity or frequency here is used. So look at the electron. The electron is not just ejected and sit on top of the surface. It has a what? A movement. It shoots there. So now we say that the energy that the light has is greater than the work function, which means the photoelectric effect as well here, the photoelectric effect has occurred, right? If it has occurred, it means that um, the 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 energy that the light has is sufficient, is equal to the work function, is distributed to the work function, and the kinetic energy maximum. So these electron, this electron now, it has a what? A kinetic energy. We call it, it's a kinetic energy maximum, right? So the extra energy that was supplied here is converted to the kinetic energy, or an excess of the energy, because it was more than the work function that is needed. So this excess is converted to kinetic energy, which is the kinetic energy is the what? Is the energy due to movement. So these particles, they have a what? A speed as well. That speed, we call it, it's a maximum velocity. So the photoelectric effect, it occurs when the energy of an incident light is equal to the work function, or it's greater. So we can summarize it by saying photoelectric effect occurs in this case, two cases, when the energy is greater or equal to work function. The photoelectric effect will occur. The formulas to calculate the kinetic energy of photoelectrons, right? This formula, it comes from, I've started from here, that energy when is greater than the work function, that means that energy is the sum of work function and the kinetic energy, right? The maximum kinetic energy of photoelectrons can be calculated by this formula, right? Guys, whenever you write this formula, do not forget the subscript of the maximum there, right? The energy, this energy is the energy of light, which is the photons, is energy is equal to hf, and then that's the Planck's constant, that's the work function of the metal, which is, that's the formula, and the kinetic energy is half mv squared, right? Very important, guys. So you can simply say here, you can simply use this formula. In the E, it will be hf, and then the work function equal to, you can say f that, and then here you can say half mv square maximum. The maximum is important there. You can even change the frequency here by saying hc over lambda equal to, and change this threshold frequency there, and c over threshold lambda plus half mv squared max, depending what you are looking for and what you are given. And very important, this mass is the mass of the electrons, which is, it's 9.11 times 10 to the power negative 31 you were given in the data sheet, right? It's the mass of the electrons.